Oh, he said it. Website. Remember, if I'm doing a website for somebody and they've given me a bunch of pictures and stuff, now all of these things apply to that company that I'm doing this website for, right? I have to be very careful about all of those assets that they've given me, because now I am responsible to make sure that those aren't accidentally given to somebody else. Hopefully they're all things that they want to be available to the public on their website. I've lost my mouse. There it is. But yeah, working with websites can actually be pretty tricky legally.
You know, the funny thing is, 99% of the websites, if you left click or right click, you can see the code.
Yeah, it's interesting, isn't it?
Yeah, I find it hard to go to a website and not do a right click.
Is that because you're a web dev person?
Well, I mean, I'm pretty sure there's a way to. I know when you got a right click,
Hides it. Because it's just being generated by that PHP, so it doesn't really exist.
Yeah. It's on a server.
Just there in that moment. Sorry, for some reason the Rebel thing is not letting me go back and forth. I hate it when it does that. Why are you doing this to me?
Where are you trying to get to in Rebel? Some websites will put a bunch of stuff.
There, it'll let me see it. It just somehow, it depends on how I access it, I guess. Okay, last time we created our generic class, and we saw in that generic class that we could use the generic specification in our class statement, in method headers, within our actual code. We were able to put that generic specification. I found one thing on Oracle's website. Let me see if I can show it to you if I still have it up. This is on Oracle's website talking about generics. So in the Java tutorials on Oracle's site, they have some examples of using generics, and they call the angle brackets, because we were thinking about that, is there a specific name for it? And somewhere down in here, they call them the diamond. And then I also mentioned that the letter that's inside that greater than, less than brackets, that diamond here, the generic diamond, were kind of normally used, but not really specific. Well, here's the conventions that Oracle would like. They say you should use the letter E within that diamond if what you're talking about is an element. The letter K if it's a key, like some sort of ID number or something like that. The letter N if it's a number. T if it's a data type. V if it's a value, etc. And they say, of course, you'll see these names used throughout the Java API. And we've seen with our book that they pretty much stick with the E for an element within that decision diamond.
So, isn't key, number, type, value,
yeah,
subsets of elements?
Yeah, they are. So it's pretty vague. And the diamond itself is just that greater than, less than thing that we're putting that all within. So when we looked at our generic class, we saw that we could do our stack. We could create our stack that used strings or a stack that used integers, and we could use that same stack class. let's focus in this one on a method. I told you that one method that really lends itself to using generics is printing, because a lot of times we want to print different data types, but we want to do the same thing with them, print them. So this example is a real short little one that gives us a really nice generic method. So let's create a new project for it. And I'm going to name this project listing 19_2. And then I want to create my main class as generic method demo. Now, looking at our generic method demo, we're going to create a main method that just calls a generic method repeatedly. So let's create our generic method first. I'm going to come down to the end of our main method. And we're going to create a method to print. And we want to be able to print an array. And we just don't care what data type is in that array. We'd like to be able to print the contents. So it's going to be a public method. Okay, so let's look at that method header then. We can put some comments above it to kind of specify what we have. This is the kind of method header that when you're teaching C#1, you hope that you never have to get to, because they're all like, what? So first we have public as our access mode, then static. When we mark a method as static, we're basically saying it's unique. Only one can be loaded in memory. So if I have a method like this that's going to expect as input some sort of array that could be giant, why would I want to mark it as static? If I didn't mark it as static and I was able to instantiate,
Could end up eating up a lot of resources.
yeah, I could have 50 objects all instantiated that all have arrays of 32 kilobytes inside of them and use up a lot of memory. We don't need anything in this method that's specific to the instance, so we can just pass an array to it and print it out. So we don't need this thing to exist in memory for each instance. Now, next, we have our generic specifier. Then the void is going to be our return type, which we don't have any of. Print is our method name, finally. Bless you. Now, within our parameters, we're saying that we have a generic array that's going to be passed in, and list will be the name of the parameter array. Some of the last few chapters that we do, we'll see some of our method headers getting like longer than most of our code. So we have a lot of things that we can put in there to eliminate code from the body of the method, basically. So, for example, in this method, we're going to get by with just a simple for loop. We're going to say that we have an integer named I that we want to start with a value of 0. And we want to run our loop until we get to the length of our list. that array that was passed to us. And of course, we're going to increment I as we loop. Now, within our for loop, we're just going to print that list item at our subscript I location plus a space. Now, after our for loop, we're going to do a blank line.
That will print all. Is that intention?
Yeah, we should be okay with it. So our arrays are going to be super short, but it would be a problem if they weren't. So let's create those super short arrays in our main. First of all, let's create an array of integers. And we'll call it integers. And we're just going to go ahead and give it some values, 1, 2, 3, 4, 5. And then let's create an array of strings. And we'll make them places to go. Better put double quotes around Austin. Bless you. Now, how do we call our method? We normally would just put print integers. Now, if we do our call this way, the compiler will determine the type. We didn't tell it when we did the call, right? So the compiler is going to have to do a little bit more work here and say, well, I'm trying to instantiate this generic, and I see here that we're calling this method, so now should be my generic instantiation. What data type is this going to be? It's going to be whatever data type this argument list is, and then it's going to have to refer back to that list to see, oh, it's an integer type. Now, another way that we could call our print then is with a little bit more information. We could specify our class name, generic method demo, and then after our class specification, whoops, we do it right. We would have our dot that allows us to call our print method, but before our method name, we would specify our data type. So we could do it that way also. Now, the second way, the compiler is still going to determine the data type, but we are supplying it. So, I mean, either way, the compiler is going to instantiate that generic right here at this point in our code where it can figure it out now. Like, what is E? Oh, E is an integer for this situation. So that's what I'll make it as an integer. So either one of those will work. We'll just go ahead and call it twice and let it print out twice. That's fine. And then we can do the same thing with our strings. We could just call that print method, or we can use our class name and our data type within the generic diamondy thing, and then print strings. Oh, I need it to say strings there, huh? Or string. Now, that was really cool because it showed how the compiler is catching it and saying, wait, you're trying to use the wrong data type here. Now, let's see if it works.
Variable type declarations, are they necessarily needed for grammatical purpose or user purpose? Because I thought it worked without.
Yeah, it should be fine either way.
You might need to,
Yeah, it's looking like it's not going to let me. Ah. Silly net beans. Finally, see my output. So I've got my integers array printed out twice with the two different call formats, and then my string array. Where did you see that warning, David?
Where you thought that Jenny meant that general, I don't know what you call your file name dot.
Right here.
Bracket of the variable type. That it's not necessarily needed.
Right.
And then the function name.
So you can, so whenever you're looking at this long syntax, can you see any benefit to doing it that way? It is more information. Whether that would be helpful to you or not. Exactly, it wouldn't help the compiler. Just the poor programmer that's looking at it. So if yours works, awesome. Now notice how using that generic specification is making our life so much easier, because now instead of having a method that prints integers and another method that prints strings, we can just use this method that uses our generic specifier for both of them. Could we use that one to print out an array of doubles? Sure. We could use it to print out an array pretty much of most different data types. Yeah, I'm sure we could find something to break it. I don't know if that would break it or not. So that's a nice little example. I like that one because it just shows us very quickly how we can implement generics with a method. And that's where you guys are going to see generics being the most useful. When you have a method like this, we could create this method, print, and we could have it one time, expect a parameter of an integer array, and then we could create our print method again and have it expect a string array, and that overload would work. We wouldn't have to worry about a thing. The runtime would take care of it. We would just have a lot more code to maintain and a lot more code to worry about. If we decided then that we needed to be able to split and not everything print on one line, how easy would that be for us right now? Let's see, we should just be able to come into our print statement, and instead of adding a space after the item, let's do a \n. And now if we run, not much difference, right? Because I was doing a print line. So duh. Yeah, let's make it a print. Okay, so I'm making it a print with a space. And then we see all of our array on one line. I'm going to leave it a print and put our \n, and you guys get the idea. And run it again. And now I should have everything on its own line. So just with that minor change. So if I had this in an application where I was calling it to print integers, and I was calling it to print strings, and I was calling it to print doubles, and I was calling it to print decimal values, I just now made one change that affected all of those. So my life was a whole lot easier, hopefully. Now, what would happen if we didn't want to change them all? We have to split some out, right? And go back to some overloaded methods. But in general, the generics are going to help us. Okay, let's put that one to sleep. I'm going to close all of these. Do what? With that duet?
Using the printf with the generic value representation. The older variable for it.
What's it do?
The same thing.
Same thing.
Yes. Different ways of looking at it.
Just another way. Okay, in this next example, let's create a new project. We're going to have two that kind of go together, and these ones will be short also. We have listing 19_3, and let's make our main class be bounded type demo. Now, in our bounded type demo, we are going to be using our geometric object class and our circle class and our rectangle class. So let me find those here. And I'll put them on the chat if we need them. Find the right one here. Helps if I'm looking at the Java. Okay, so here's our geometric object class. Let me send it to you. And I want the circle. Find it. C's are way far from the G's there. And the rectangle. Okay, that should be all of them. All right, so I want, in our bounded type demo, I want to add these classes. So I'm going to see if I can just drag and drop. You guys have already figured it out, right? See if I can just take them into that default package. Let me drag you, you silly thing. Okay. So letting you guys open them. Because for me, it's just since I sent them to you, it gets really wacky.
Where do we need to add them to?
Let's
In the
add them
package?
into our default package. So there's my geometric object. I'm going to find my circle.
From the chat, I downloaded them to the desktop. With the Zoom open. Oh, sure. Click on the chat and it'll appear a box in there. There it is. Yeah, why do I always...
Is it being mean?
He's got nothing in his chat.
Ah, is he in our group?
Yeah, I've been open. She sent it. He opened it after. He opened it after, so he doesn't get it.
Oh, okay. Let me send him again.
Where's the link from the Zoom meeting?
It is on the main page with my picture. The instructor page, if you go to our home page.
You got them in here. You should be able to drag and drop.
Okay, here's the rectangle again.
Said it goes to the source, correct?
Yes. And our circle. And the geometric.
Go to files and do it as the source.
Okay, so what I did is I saved each of these to my file system, and then I was able to right-click and copy in File Explorer, and then right-click and paste to paste them into the project. I had to do that copy and paste because I kept trying to move them from my file system, and I wanted to keep them out there too, so I copied and pasted. All right, is it showing them to you now in the chat? Okay.
Now I gotta go over
See?
and try what she said, copy and paste. Let's see if it'll do that.
Paste it over here.
Yeah.
Sorry.
Oh, I didn't know. Now.
So you got that one, but I think you're not seeing the other.
Okay.
Uh-huh.
It's showing in my files folder under the source,
Yeah.
but on the project page, projects tab, it's not.
Oh, okay. Let's see, mine might be the same.
It let me open it from there, so we'll see if it lets me work with it.
Okay. This is a little teeny project. Assembling the project first will be the hard part.
In the source folder.
Okay, and there's the rectangle again. I like it because then I can say, see why I want you guys to load your whole projects to GitHub so I can test them. I don't like rebuilding them to test them.
You want this after the last one, after 921? No. Put them in the source folder.
Put them over here in your.
Oh. I guess.
Okay, are they showing up? Everybody got them? Got them. Now, the bounded type that they're referring to in our name here, they're talking about inherited types. So if you remember, our geometric object is our base class, our superclass, and our circle and our rectangle both inherit from that geometric object. That means that they're a bounded type. They're bounded to the geometric object. So in our example, we're going to refer to our generic as a geometric object. And then that will work for our circle and our rectangle because they are both types of geometric objects. Make sense? So that's going to be our bounded type here is our geometric object type, that superclass, so that we can get everything to work together. So we don't have to do a lot here in our tester, we've gotten all that stuff pulled together. Let's start out by instantiating a rectangle. And then I want to instantiate a circle.
Did you have to add an import to that, or did it take it?
It took it, but I don't believe it. I think it's lying because I'm not getting color coding. So I think it's gonna.
Fine.
Did yours color code it and be all happy?
Mine's not taking it. Not there.
We will figure it out.
No, none of it's mine. I think it had to do with the fact that it was in a separate location.
Ugh, what am I doing? I was listening to you guys and I got off there onto the wrong thing. Okay, so in our main, we'll figure out if it's being able to see all of our classes and stuff here in a second. Let's put our code in and then we'll get rid of all of our errors, which we might have. Right now I'm getting an error on my equal area method because we haven't created that yet. But this is how simple our main is going to be if we can get everything to work. We're going to create a rectangle, we're going to create a circle, and then we're going to figure out if they're equal to each other. In our earlier exercises when we were working with our geometric objects, we kept our circles separate from our rectangles because they didn't have the same type of capabilities, the same type of measurements. Now we're kind of putting them together and saying they're both geometric objects. Can we check to see if they're of equal area? Let's create our equal area method and then we can resolve our issues. Now again, our equal area method is going to be a static method.
All right, here's where I've got all kinds of fun problems.
What's the matter?
My equal area accepted. It's saying it's there. It's the circle and rectangle it doesn't like for some reason. But I got to refresh that. That's what I
Close it and open it.
Yeah, I'll give it a shot and we'll see.
Restart that sucker.
Try to save it and then try it again.
Were you? So I think I'm going to save all. And a lot of times when you're copying and doing classes like this, saving everything will help too, with NetBeans getting buggy. So because we want this method to be able to understand anything that's a geometric object, we're going to use the extends keyword to say that our generic object E extends geometric object. And then we'll put some comments in. To further define what's going on there, because we're really just going to have one line of code in this method. So some comments for our method. First of all, public is our access mode. Again, static, only one instance. Now, where we get involved in this one that's a little bit different than our last one is E extends geometric object. Now, if I can get this comment in here. Basically, E is a bounded type generic. Whatever is passed to us in this generic specification will be some sort of geometric object, right? So why this is important is, in our print example, we said our generic was wide open. We took strings, we took integers. What if we had something where we could only use numbers? We don't care what type of number. We'll use integers, we'll use doubles, we'll use decimals, we'll use longs, whatever you have, that's fine. But it has to be a number. Well, then we could use this bounded type and say E extends number, right? Because that default system number class, all of those other types of numbers inherit from it. So if we look at that internal Java setup, we can say, oh, we could use a bounded generic of number, and then any data type that was a numeric data type would be allowed. Next, our return type is Boolean. Equal area is our method name. Now our parameters for this one, we say that we want 2 objects will be passed to us as parameters. Each of these objects will be of the geometric object type. So one could be a circle, one could be a rectangle, could be 2 circles, could be 2 rectangles, could be a triangle if we made our geometric object class that created a triangle. We know that if this object is an extension of the geometric object, it has to have the get area method. Because remember, our geometric object way back said that anybody who inherits from a geometric object has to implement the get area method. So we know that get area method will exist, so we can use it in this method to decide if the 2 objects are equal or not. So does it run, or do you get a bunch of errors?
I actually got false.
Ah, awesome. It works. I don't know, is there a way we could get them to come out the same? I guess we could try another rectangle. Oh, you're so picky.
I do it now.
Rectangle. And then I'll compare my 2 rectangles and make sure I get true, just because I got to test it and be sure. Ah, yeah, so it works with the 2 rectangles. So everything is okay there. So how we could use something like this is we might have a person class that we inherit from. We might have persons that are employees and persons that are students, but we know that each of our persons has a get age method because we require that of a person. So we could have a method that compared their ages. We wouldn't care whether it was a student type person or an employee type person. We could just say, they're a person, they're bounded as a person. Does that one make sense? Everybody got it to work? Good job copying all that code around. Now, in the first case study in the chapter, which you probably want to go through, they set up some different arrays real short and use the array sort method to sort them. And then they use kind of our generic print method that we just created to print those arrays out. So it just takes that generic print method a little further than what we did. I was talking to Jim earlier before everybody got here. If you notice with Ravel, we don't have as many videos here at these later chapters, like this chapter has none. And that's about how many videos you'll have as we keep going. So just like a lot of other textbooks, they do really, really good on those early chapters. And we were lucky with us, since we were starting in the middle, that our early chapters like inheritance and stuff, they had a lot of good videos about. But we'll get to fewer and fewer as we go. The later chapters, they're kind of like, nobody ever gets there. We'll start running into more typos and things like that. So luckily, you already have this good background that it won't be a problem for you. Okay, so let's do comparing two objects. I'm trying to look to see if what all we need to copy. I think this is going to be our generic class that we did last time. Let's try it. Let's create a new project. This one is a little vague, so we'll see if we run into trouble. This is going to be 19_5, and in our main class, we're going to call it Max. A few weeks ago, you guys created a Max method. If you remember that assignment, and it may have been those geometric objects. You had to create a Max method to say which one was bigger of the circles, which one was bigger of the rectangles. So if we needed to implement that in a generic way, we might want to do things a little bit differently. We're going to create this Max class. And the only thing that we're going to have in it is this Max method. And after we get a little bit of this in here, it'll become a little more familiar to you. So our Max method is pretty interesting here. Let's put some comments. Public, it's our access mode. I'm going to start leaving that out, but these things are so long. I want to really document them so that it means something to us. Only one instance. Now, comparable here is saying that this Max method returns, our return type is a comparable object. So kind of like whatever type of object we were comparing. Max is our method name. And then our parameters are using additional comparable objects. So we are seeing right away that comparable means something to Java. We didn't create this comparable class, yet it's being recognized. It's okay. So a comparable is kind of like a base object. Just, I could have the keyword object there and say it's an object of some sort. I don't know what kind, but it's an object. And these two parameters that are being passed to me are two different objects. And I just want to be able to compare them to each other to decide which one is greater than the other. Now, this ugly if statement, remember that Java syntax when we used the compare to method, we sent back like -1 if the first one was less than the second. We sent 0 if they were equal, +1 if the first one was greater. That's what's going on here. It's using that same compare to method to do this comparison. So we want to break it. Let's compare. We're going to call our max method here in our max class. We're going to compare this string to this integer. Now, what we're doing in this example is using a raw type. The comparable type. So we're not using a generic. This is the old way of doing it before generics were available. So that we can see what kind of problems we can run into. And sure enough, there's our problem. Said that I can't cast this integer as a string. You're asking me to do that. Let's try to run this comparing two strings. Welcome and hello. Oh, if we run it that way, it's running. We don't get any output. Yours didn't?
No.
We should be able to run okay if we're comparing two of the same data types. I think you did. Clear that.
For two.
What is the equal?
It still thinks there's an integer string. I don't think it is reading it to say, do the
Showing that it was saved.
I think it's just because it's left over, it's not enough of a change for it to recompile, but that should have done it. Well, we'll fix it. Now let's make this a better max, because this max is not working right. Because if we send an integer and a string, we can break it.
I know why it's working.
Do you? Good.
Yep. My returns,
Uh-huh.
I had letter or number 0, 1.
Oh, okay. So it's doing something.
That, and it's still done. Seriously. No, because the compare to was done that way as well.
So let's do a different one. Let's say that instead of calling this max, we're going to call it max E. So I'm going to create the same method, public static, and then instead of saying comparable there, we'll use E to use a generic and say this extends the comparable object data type as a generic. Now our other stuff should be exactly the same, so I'm going to try to copy this. Now we saw that we can't run that max method with a string and an integer. What happens if we try to run our new max e method with a string and an integer? Ah, the compiler catches us, and right away it says, these are inconsistent generic types. Our generic specifier says that it has to be compatible types, and those are not compatible types. So this is just an example to show you how the old school setup could work in certain situations, or it might let errors get through, just like before generics existed at all. And now that we have our generic specification, we can make the compiler catch those errors for us. So generic will just keep us all safe and keep us from making mistakes and doing bad things. So great. The last little thing that we need to look at is wildcards. And our generics can be really simple, like we saw last time, where we're just using that diamond in a letter to be a placeholder for our data type, which is how most of the generics you see are going to be set up. Or they can get really, really complicated using these wildcards. If your max method is working properly, is everybody okay with that one? Or we need to look at something? Got it? Got it? Got it?
I got a little red.
Yep, it should. That's what you're wanting to see, that now it's not going to let you have that runtime error. Right, and then we've got two
Yeah.
strings. So everything's fine.
Awesome, thank you.
Yeah, because now you've got consistent data types.
We're just breaking.
And you can run it without breaking. Oh, yeah. That's fine, because we didn't do any output. You're just returning the value. So that's our program. It's just running or crashing on this one. So if it crashes, it's because we have inconsistent data types, but then the generic keeps us from being able to do that.
It lets you
Yeah, it lets you know. It says, no, you can't do that, silly. You're going to break it.
know. Okay, it's telling me that on the front end.
There you go. So it's kind of weird. You have to really think about it, because we're used to problems happening at runtime. And it's like, no, I'm going to keep it from happening at runtime. Okay, so this one is the same way, this next one. This listing here is going to show us why we need the ability to use wildcards in our generic. So we're going to have a problem with it, and then we're going to come back and use a generic wildcard to fix that problem so that we can see how they impact things, because they're kind of hard to talk about. So I'm going to close this one. Save it. And I'm going to create a new project. And this one will be listing 19_7. I want my main class to be wildcard need demo, because we're going to demonstrate why we need these pretty interesting syntax wildcards. Now for this project, we're going to need our generic stack that we made in listing 19.1. So I'm going to copy mine and I'll paste it to the chat in case you don't have it. That's not what I want to do.
I go to open new file, a new project.
It won't let me do it, you silly thing.
Hit some stuff.
Said we needed the listing 19.1,
Yeah, listing 19.1,
and we just need the job
generic
title, right?
stack, yeah. I looked at where mine is and now I'm like, where is it? It just won't let me copy it from there. Okay, so it's on my H drive,
Go up
171.
here where it says wildcard demo.
Yeah.
There on the files thing.
Uh-huh.
No.
Oh, right there. Okay, that'll
Right
help.
there up at the top. Over your node. Over your node. Where it's got the green.
This
menu,
one,
wildcard
uh-huh.
demo. If you right click it, you can copy the file path. And just paste it into file.
And that's not the one I need though.
Oh, right.
But I think that I can use this file screen though to get it. I think you're on to it. If I,
You think it says go to file location or something.
yeah, it should. Just having a hard time today. What was that? Let's see. I've got this list here of all the files. I'll just get it from them. Our generic stack. Oh, nope, they don't have it there. Be faster for me to just show you my GitHub stuff. Does anybody else have it? Can you just post it to the chat?
I've got it in chat.
You got it in the chat? Because if you guys can just post it there, that'll work.
Well, they're both the same from the other one, aren't they?
Yeah,
So we can just drag them down.
just drag it down, but I just need it in the chat in case someone wasn't here when we did that the other day.
You need the generic stack demo is the one we're talking about.
Mm-hmm. Yep.
Would you care if it's just the code?
Just the code should be okay. They might have to do some work there to fix it.
Just make sure you name your class or generic stack.
CIS171. Why can I not find
Oh.
this?
I've
Git.
got the one that we did, I believe. No, that's somebody else. Yeah, David got his in there. So it's there.
If you guys have gotten it, I'm going to quit looking because mine is just, should be right there and it's not. So I'm going to copy it down to our new project. Now, in my generic stack, I told it to refactor as it copied, but it shouldn't matter because I'm using the default package. That would have been the only thing that I needed to change was that package name. If you remember, our generic stack from the other day was our first class where we used a generic. So we said we're going to build an instance of a stack, like a stack of plates or a stack of pancakes, and we have these certain capabilities available to our stack, like we could add members to our stack by using the push. We could look and see what was at the top of our stack using the peek. We could take something off the top of our stack by using the pop. So those were our different methods that we created for our generic stack. So we just want to take this a little bit further. So in our wildcard need a demo, in our main, let's create a few instances of that generic stack. Actually, just one. We'll create a generic stack that uses integers. We'll call it int stack. And remember, we had that weird constructor code where we have the diamond for the generic followed by the open and close parenthesis for our parameter list. Now we want to add to our integer stack, so we'll push a 1. Now this integer is going to be auto-boxed into integer 1. So it will be taken from a native data type, int, and boxed into an object type integer. Because remember, our generics don't use those native data types. Now let's push another integer onto our stack. This one will be 2. Again, he'll be auto-boxed. The reason we care about that auto-boxing is that's using resources behind the scenes. Then we'll push, let's push a -2. So what's at the top of our stack? -2. Now let's output the max number is. Now, right now, we haven't developed our max method for this class yet, so we will. That should be all we need for our main. So outside of our main, let's declare our max method. So this is kind of interesting in our application here. We want to demonstrate the need for a generic capability, but we're using generics. Now in our max method, we're going to start out by declaring a max variable and initializing it. If you're thinking, that doesn't seem right, you're right. I'm just going to put this code in here. And after our while, we return this max value. Well, as I'm looking at it, as we were typing it in, I'm thinking, well, that doesn't make any sense because we built this stack of integers And as soon as we get started down here, we're popping a double out of that stack. That's gonna be a problem, isn't it? So we don't put any doubles in there. So we're gonna have some sort of failure. Remember, this one is trying to demonstrate why we need these wildcards. Right now in our generic specification, we've said we're gonna take any sort of number. That should be okay, right? Because an integer is a number data type. A double is a number data type. Is it okay? No? What's it complaining about?
Well, that double is in an integer, so you can't just swap.
Saying cannot be converted to that. So we have an issue. According to them, we should be able to run it though. They're showing that error, the incompatible types coming out at runtime, but we're seeing the compiler catch it. So I would hate to say that NetBeans is smart enough to do that, but it looks like it is. Because according to our text, we should be able to run it this way, and we would get a runtime error because of those inconsistent data types. But it's actually catching it. So how could we fix it? Well, we want to use a wildcard. The first type of wildcard that we can use is called an unbounded wildcard. So what we can do is use the extends keyword, but we can use a question mark. So right here where we have generic stack, we're going to put question mark extends number. So now it's going to let us. Is that good? Let's see. It took it okay.
It's funny, it told me,
Did it not take yours okay?
it said bad compile, run anyway. I said yes, and it said fine.
Never say yes if it won't compile. Say no, no, no.
One of the projects was compiled with error.
So by us adding this question mark and extends, we're saying it doesn't have to be a specific number data type. It can be any type that extends from the number class. And so that wildcard is just giving us that capability of saying any of those types.
This is interesting.
Mm-hmm.
If you look at this,
Yeah, so just say cancel, you never don't run anyway.
two.
Because it's just running with the whatever last version you had compiled. But why is it giving you?
Yeah.
It's there.
It's saying it can't compile.
But it runs.
Is it like one of your projects can't compile, or is it saying this project?
Just right click on this one and just say run compile.
You can have a project. open.
No, it's this way.
Oh.
It's
Have
weird.
you saved?
Make pack.
You can try and save, because NetBeans does get weird about that.
Yes. And there's three options with it. Depending on what you're doing, it's
Doesn't see any error.
book, I forget which section it is. Covers it pretty well.
That's being weird.
It breaks it down pretty good right down here. What they do. Yeah, this one right here. Kind of gives a good visual.
Well, there's nothing wrong with that one. It's just telling you that there is something.
Uses, yeah, and helps for what purpose.
Is it okay with that one? Is it just that other one that still has errors? Well, we had errors in that last one that we just left.
Probably this one. Thing, it's got a problem, but it works.
That beats, gotta love it.
The weirdest thing I've ever
I
seen.
really think
Okay. There's nothing wrong with it. It's just
computers have something against
They really don't.
The same exact code I have, and the same exact code she has, and it runs perfectly fine. So I mean, it's just telling you there's a problem, but there's not.
Yeah. It's saying, I'm gonna be difficult with you.
Now this wildcard, the bounded wildcard, is saying we'll take any data type that is part of the number. If we put a question mark here, then we kind of go back to we take any data type. That would be the really open wildcard. There's a little bit more information about the wildcards in your chapter. And at the end, the last case study that they do is 2 matrices that they add and subtract together. It's pretty interesting. Again, it won't take you very long if you want to take a look at it, because the projects in this chapter are kind of nice and short since we're just focused on the generics, thank goodness. Sometimes they're like 4 hours long, so these ones are a little shorter. So take a look at them. Be sure to do the practice test for the quiz, because there is some really interesting terminology in these wildcard setups and the way they ask you those questions. Any questions about this stuff, though? We're pretty well good with our generics. Get out of here. Have a great weekend.
Get out of here.
Have a good one, good one. I should push all this to GitHub, shouldn't I? I'll probably have a big giant mess if I do.
Question. The next project that says shuffle, is shuffling the same as sorting? Is that a question, or is it different?
Sorting is putting them in order. Shuffling is
Just
putting them in
moving
random
around?
order.
Okay, I was wondering if that's what
Yeah,
it
kind of
was.
like shuffling your deck.
Okay.
So they should be super easy.
Yeah. It looks pretty easy. So I was
Last time I even told everybody, if it seems real easy, it is.
Yeah, you too. You want it.
I'm gonna try to make.
Why are you appling? Eating lots of apples.
Because he's so healthy and he's.
Oh, I was wondering.
We always talk about in the other class what we eat.
Oh, I see. How healthy you are. I feel so bad in my 120 class. I have a guy who has the alpha-gal, the allergy that I have to red meat, and he's back this week, but the past 3 weeks, he's been to the emergency room like 7 times in and out of the hospital. Talking, because so we were kidding this morning, and I said, so have you figured out you just have to stop eating? And he said, yeah, I'm just not eating anything, and I feel good. And I was like, yep, that's what you got. No food. That's our idea of fun.
I'm gonna have to borrow one this week.
No, just keep it though, because I don't want it back.
I got coffee in here.
Oh, well, that might not be enough.
I have no idea.
I think
Do we?
I had it empty.
For the other class. So we're gonna spend your project. That's the final, I believe.
Oh, I hadn't looked at that. So that's news to
Yeah,
me.
we need to. I think it'd be a good idea if we thought about it.
You want a color. Let's find you a color.
So I live in Clare.
Hmm?
I said I live in Clare.
Uh-huh.
That's being even more annoying than I thought it would be.
Is it?
Like on Tuesdays and Thursdays, most of the time I get up at 5 to come here.
Uh-huh.
Done the
And we get up at 5 o'clock in the morning and the car doesn't start. Not very many people that'll get up and jump.
No, there's not. Plus, like with my husband's truck, it has a special feature where if it's super cold, it just,
Oh, wait a minute.
that's too close. It just won't start.
But that's not my stupid car.
Is it?
It seems
We didn't know, but that's actually a, okay, I'm gonna give you the ugly yellow. It's actually, his is a Dodge Dakota, and it's actually a Dodge Dakota known thing.
they just don't like the cool.
Well, there's something, it's some part that over the years they think develops like a hairline crack, and then if moisture gets in there when it gets too cold, it freezes, and then the wires can't make the connection because they're pushed just far enough. So it's one of those really long involved things. In the end, you cannot buy the part unless you find it at a junkyard, and they cost like $300 or $400. So I told him, I guess when it's really cold, he's gonna have to get a ride to work. But what's weird is we didn't have any trouble with it this winter. Last winter we had trouble 4 or 5 days where it wouldn't start.
Last winter, I only had problems once. In South Dakota, and it
So
was negative 40.
oh my gosh, yeah, that's
This
so much
winter started like
colder.
4 times. And I have it's like a new Subaru.
Were you
too.
plugged in up there? No, you didn't have it plugged in.
But
No
you know,
garage?
I have a carport.
Yeah.
So I'm like, maybe that
So I
will
wonder if your wind is coming like,
What file do you
because
want?
that's all, I mean, we have a carport this year where we didn't last year. So I guess his truck is getting, but I mean, he would park like right up against the house. So I can't believe that it's getting more protection this year. But that's weird for yours. It seems like it must just be a
Yes.
certain
See you
type.
I was so
Monday.
frustrated this morning.
I'm gonna try
I'm car this afternoon.
Don't do that. You have to wait until you're ready. You'll never want to do it when you're mad. Stupid cars. I don't know. Okay, so you get the idea?
So we're writing what's being printed on the screen.
Yes. And put it on the back with the sticky side, even though with you nobody would be stealing your answer. I looked up today and someone was doing this. Hey, what are you doing? No, just remember that that's your color. And then when we look at them Tuesday, you'll be able to see how well you did.
Yeah.
Thank you for the notes, by the way.
Sure.
It'll be help.
Just something to talk about is always helpful.
You get us all on there, or did we all get on there?
Everybody's on there, man.
Guys on there?
Hmm?
Guys on there?
You did? Wow. I couldn't even find it because you're usually one of those answers. With 15, I can handle it. It's those 25s I can't handle.
I walked into Kirsten's class. I mean, I got confused on what day it was.
Uh-huh.
Like, walk over to my seat, there's someone sitting in my seat. I'm like, okay, I'm gonna go sign in, wait for him to leave. So I go sign in, I'm like, my name's not here. Okay. So I stood there for a solid 5 minutes before I realized
I'm
this is
Robert.
the same people.
Not the same group at all. I had one, because if they gave programming class on Friday.
Yeah.
My C-sharp one guy came over to me, like the second Friday, I missed it. I just got me out of the class, and I was like, didn't want to drop you. Why is my name not on the list? You're not in this class? And finally I was like, did you lose Friday? Because he's so curious, I don't even know how to say it. And he was like, it's Friday? Oh, yeah, I missed Wednesday. I don't know what happened to you there,
I've done
but
that.
you might need to check your phone before you leave in the morning.
Well, I have 2 classes at the same time. Like, so I have Monday, Wednesday
Oh, yeah.
in her class at 11:30, and Tuesday,
Uh-huh.
Wednesday with you. And so, like,
No, but you don't understand.
it's like every day I walk in, like, what day is it? So what day do I have? What class
It's
do I
just
have on
that
Wednesday?
if you end up in the wrong place, you get mad at everybody else. Then there's an
Yeah.
anger management issue. It's not about being in the wrong place. That's what that guy was like, chill, dude. See ya.
That's just changing your pattern.
Yeah.
And then that will grab the index I, minus plus and minus one, change it to maybe 8%, 60% for I plus 1 plus 2, and I is greater than
This is Java 2.
okay. Then you
Yeah, it's the advanced stuff where some of the stuff that we get to at the end is pretty tough.
How about you ready to do it?